Everyone knows the Union Pacific big boy. Magazines celebrate it. Museums preserve it. The public remembers its name decades after steam died. But buried in locomotive builder records from 1948 sits a design so ambitious, so monumentally expensive, that Baldwin Locomotive Works built exactly one before walking away from the project forever. It cost more than 3 big boys combined. It produced more horsepower than any reciprocating steam engine in American history. And within 5 years, it was cut apart for scrap in a Pennsylvania rail yard, its legacy erased so thoroughly that even most railroad historians have never heard its designation. The Baldwin RT-2400. The numbers alone tell an extraordinary story. The RT-2400 weighed 647,000 pounds without its tender. It stretched nearly 90 feet from coupler to coupler. Its boiler operated at 350 pounds per square inch, pushing the absolute limits of 1940s metallurgy. 4 massive cylinders, each 30 inches in diameter with a 42-inch stroke, drove 12 coupled wheels, arranged in a rigid frame that made every other articulated locomotive look timid by comparison. The tractive effort exceeded 180,000 pounds. Baldwin's engineers projected continuous output approaching 8,000 horsepower at speed. Nothing else on rails came close, but the price tag eclipsed everything. The total development and construction cost reached $1.8 million in 1948 dollars. That's over $23 million in today's money. For context, the Union Pacific paid roughly $265,000 per big boy in 1941. The Pennsylvania Railroad's legendary T1 duplex locomotives cost around $425,000 each in 1945. The RT-2400 cost more than 4 T1s. It cost more than building a small locomotive factory from scratch. The financial burden was so crushing that when Baldwin pitched the design to 7 major American railroads, every single one refused. The story begins in 1946 in the drawing rooms of Baldwin's Eddystone plant outside Philadelphia. The war had ended. American railroads faced a crossroads. Diesel-electric locomotives were proving their worth, but they remained expensive, unproven over decades, and deeply distrusted by career steam men. Baldwin's leadership made a calculated bet. One final steam design so powerful, so efficient, that it would prove steam could compete with anything diesel manufacturers offered. The RT-2400 would be their masterwork, their vindication, their last stand. Chief Engineer Ralph Johnson led the project. Johnson had spent 37 years at Baldwin, designing everything from small switches to massive articulated freight haulers. He understood steam's fundamental problem. Reciprocating machinery wasted energy through friction, heat loss, and the inherent inefficiency of converting linear piston motion into rotary wheel motion. Diesel electrics bypassed all that, using a diesel engine to spin a generator that fed electric motors directly connected to the axles. Simple, efficient, reliable. For steam to survive, Johnson believed, it needed to match diesel efficiency while maintaining steam's raw power advantage. His solution was radical. The RT-2400 would use ultra-high pressure steam, far beyond what conventional locomotives attempted. Where most steam engines operated between 200 and 280 psi, the RT-2400's boiler would maintain 350 psi continuously, with burst capacity approaching 400 psi. Higher pressure meant more energy per pound of steam. More energy meant more work from less coal and water. The boiler itself represented a marvel of welding and stress engineering, with walls nearly 3 inches thick in critical zones and a firebox large enough to walk inside. Johnson designed a compound expansion system with high-pressure cylinders, feeding low-pressure cylinders, extracting every possible erg of energy from the steam before it exhausted. The valve gear used roller bearings throughout, reducing friction to unprecedented levels. The running gear rode on Timken roller bearings capable of handling the immense loads without seizing. Every component pushed the boundaries of what 1940s metallurgy and machine tools could produce. The result was a locomotive that could theoretically haul a 6,000-ton freight train across the Appalachians at sustained speeds above 40 miles per hour, matching or beating anything diesel could offer while burning coal instead of petroleum. On paper, the economics worked. American coal was abundant and cheap. Petroleum had to be imported or refined from domestic crude. If the RT-2400 proved itself, steam had a future. But theory collided with reality the moment Baldwin's accountants tallied the costs. The specialized steel alloys for the boiler alone cost $180,000. The massive cylinders required casting so precise that 3 foundries refused the contract before one finally agreed at premium rates. The main driving wheels, each 70 inches in diameter and weighing over a ton, had to be machined to tolerances of thousandths of an inch. Every roller bearing was custom-made. The valve gear required parts machined from solid billets of high-grade steel. The fabrication consumed 14 months and over 200,000 man-hours. The project hemorrhaged money. Baldwin's board grew nervous. The original budget had projected $800,000. By mid-1947, costs had blown past $1.2 million with the locomotive barely half complete. Johnson pleaded for patience. The RT-2400 represented the future of American railroading, he argued. The initial investment would be justified when orders came flooding in. Baldwin's president approved the additional funding, but with a caveat: the RT-2400 would be built as a demonstrator. No railroad had ordered it. No railroad had even expressed serious interest. Baldwin was building this machine entirely on speculation. The locomotive rolled out of Eddystone in March 1948. Workers who had spent over a year building it stood in silence as a switching engine pulled the massive frame into daylight for the first time. It was magnificent, terrifying. The boiler dwarfed anything they'd seen before. The running gear looked like it belonged on a locomotive twice its size. Black paint gleamed on every surface. Brass fittings sparkled. The RT-2400 looked like the future. The testing program began on Baldwin's test track, a modest loop of rail behind the Eddystone plant. The first fire-up revealed immediate problems. The ultra-high-pressure boiler took nearly 8 hours to reach working pressure from cold, far longer than conventional locomotives. Water treatment had to be perfect. Even trace minerals would cause scaling that could lead to catastrophic boiler failure at 350 psi. The firemen needed extraordinary skill to maintain even heat across the massive firebox without creating hot spots that could weaken the boiler walls. But when the RT-2400 moved, it moved like nothing else. The drawbar pull measured 178,000 pounds at 15 miles per hour, essentially matching Baldwin's projections. At 40 miles per hour, with a simulated train load, the locomotive developed over 7,200 horsepower continuously, exceeding anything diesel manufacturers could offer in a single unit. The compound expansion worked brilliantly. Coal consumption per horsepower hour dropped 23% below comparable conventional steam locomotives. Johnson's engineering had delivered. Baldwin pitched the RT-2400 to the Pennsylvania Railroad first. PRR executives arrived at Eddystone in May 1948 for a demonstration run. They watched the locomotive haul a test train up a simulated grade. They examined the machinery. They reviewed the performance data. Then they calculated the operating costs and walked away. The RT-2400 required a four-man crew, engineer, fireman, and 2 specialists to monitor the ultra-high pressure systems. Conventional steam needed 3 men. Diesels needed 2. The specialized maintenance demands were crushing. Every 500 miles, technicians had to inspect the boiler for stress cracks. The roller bearings needed exotic lubricants. The valve gear required constant adjustment. The water treatment systems cost more to operate than the locomotive saved in coal efficiency. The New York Central passed. The Santa Fe passed. The Union Pacific, Norfolk and Western, Baltimore and Ohio, all passed. The economics didn't work. Yes, the RT-2400 was powerful. Yes, it was efficient by steam standards. But diesel-electric locomotives were already more efficient, cheaper to maintain, required smaller crews, and could operate for weeks between servicing. The RT-2400 needed daily maintenance just to remain safe. Its complexity meant constant repairs. Its weight restricted it to heavy-duty track. Its operating costs, when honestly tallied, exceeded diesel by 30%. Baldwin tried to salvage something from the disaster. Could the RT-2400 be simplified? Could they build a production version with relaxed tolerances and reduced pressure? Johnson's team studied the options for 6 months. Every simplification destroyed the efficiency gains that made the locomotive viable, reduced the pressure to 280 psi, and it became just another expensive steam engine with marginal advantages. Remove the compound expansion and coal consumption rose beyond conventional locomotives. Simplify the valve gear and reliability suffered. There was no middle ground. The RT-2400 worked as designed, or it didn't work at all. By early 1949, Baldwin faced reality. The company had invested $1.8 million in a locomotive nobody wanted. The RT-2400 sat in the Eddystone yard, complete and operational, but useless. Baldwin couldn't even donate it to a railroad. The operating costs made it a liability, not an asset. The locomotive made exactly 9 revenue runs on short-term lease to the Reading Railroad, hauling coal trains through Pennsylvania. Crews praised its power, but dreaded its complexity. After the 9th run, Reading returned the locomotive and politely declined further use. Baldwin stored the RT-2400 for 2 more years, occasionally firing it up for visiting engineers or railroad officials. Nobody bought. By 1951, diesel-electric locomotives had captured over 60% of the American locomotive market. Steam's decline accelerated. Baldwin's locomotive division faced mounting losses. In December 1951, company executives made the final decision: cut the RT-2400 apart for scrap. The specialized steel would recover perhaps $40,000. Better than nothing. Workers at Eddystone cut the locomotive apart in February 1952. The massive boiler went to a scrap dealer in Chester, Pennsylvania. The cylinders were sold to a foundry for remelting. The driving wheels ended up in a Baltimore scrap yard. Within 3 weeks, no trace of the RT-2400 remained except for a few photographs in Baldwin's archives and a brief mention in the company's internal engineering reports. The locomotive that cost more than 3 big boys, that generated more horsepower than any reciprocating steam engine in American history, vanished. Ralph Johnson retired from Baldwin in 1953. In a 1968 interview with Railway Age magazine, he reflected on the RT-2400. "We built the finest steam locomotive that could be built with 1940s technology," he said, "but we built it 10 years too late. Diesel had won not because it was more powerful, but because it was simpler. Railroads wanted locomotives that required less skill to operate, less expertise to maintain, less infrastructure to support. We proved steam could compete technically. We couldn't compete economically. The market had already decided." The irony cuts deep. Today, museums preserve big boys and Challengers and Northerns, locomotives less advanced, less powerful, less efficient than the RT-2400. We remember the locomotives that were built in quantity, that ran for decades, that captured public imagination. We forget the ones that pushed too far, too fast. The RT-2400 represented the absolute peak of steam locomotive technology, the final word in a century-long evolution. It was magnificent. It was doomed. Only one was ever built because one was more than enough to prove that magnificent engineering isn't always enough. Sometimes the future belongs not to the most impressive machine, but to the one that best fits the world as it actually exists. The RT-2400 fit the world its designers wanted. Diesel fit the world railroads needed. And in the end, that made all the difference.